In this video, we're going to learn about Ohm's Law and learn how the voltage and the current and the resistance are related to one another. So current is the flow of electrons in a circuit. It's also the speed of the electrons traveling through the circuit. And the symbol for current is I. And the units for current is amperes or amps. And the letter symbol for the unit is A, capital A. So we can see here the electrons are speeding through the circuit. Now we're going to take a step back and talk a little bit about conventional current versus electron flow. So when current electricity was first discovered, it was assumed that current flowed from the positive end of a battery and went through the circuit and came back to the negative end of the battery. So that's kind of the theory that's been adopted and accepted over time. So it would show going from the positive end all the way back to the negative end. That's conventional current. But what really happens is in electrical current, electrons are actually flowing from the negative electrode of the battery, going through the circuit, through the light bulb, and then back to the positive end of the battery. So that's the direction that electrons flow in a circuit. So electron flow is from the negative to the positive, and conventional current is described going the opposite direction. We aren't going to test you on that, but I thought it might just be interesting for you to know. So you've probably heard of alternating current and direct current, but you might not know what each means. So direct current is when the current flows in one direction only, and an example of that would be like in a battery. So a flashlight or an electronic device that's operated by a battery is direct current. So we can see that the electrons are flowing through in one direction only because red is representing direct current or DC. Alternating current is a little different because the current periodically changes direction. So it might be going this way, but then will change and go the other way. And this helps current travel more efficiently over greater distances. And alternating current is what we use to power our homes. So the electricity that supplies our homes is alternating current. So voltage is the force of the electrons moving in a circuit. So they're pushing their way through the circuit. So I've represented it here with an electron pushing against a wall. We also sometimes describe voltage as potential difference. The symbol for voltage is V, and the units is measured in volts, or again, V. Resistance is the force that tries to slow down or even stop electrons in a circuit. And almost all materials have some resistance, even things that are considered really good conductors. The one exception would be superconductors. There's hardly any resistance at all. The symbol for resistance is R, capital R, and the unit for resistance is ohms, which the symbol for that is the omega sign, so it looks like a little upside down horseshoe with like little sticks on the end. So resistors or resistance prevents the flow of electrons, so it's slowing them down, telling them to slow down or stop. So we're going to take a look at the relationship between some of these concepts. So current and voltage. If you increase the current while keeping the resistance the same, the voltage will increase too. So that's saying that voltage is proportional to current. Now, if you increase the resistance, the current actually decreases. And that kind of makes sense because remember, resistance is the force that's trying to slow down electrons, and current is the speed of the electrons. So if you're doing something to slow down the electrons, they're not going to travel as fast. So current is said to be inversely proportional to resistance. Now, voltage and resistance are proportional to one another. So if I increase resistance, the voltage will increase. If I decrease the resistance, the voltage will decrease. So here's our relationship here all in one formula triangle. So we see here that V is on the top of the triangle. Remember, V is voltage. And I is down here. So that's current. And then R is over here. That's resistance. Now, if you remember, if things are above and below each other, you divide. So, and then if they're side by side, you multiply. So you cover the variable you're trying to find out. So if you know current and resistance, but you're trying to find voltage, the formula for that would be voltage is equal to I, the current, times the resistance, R. Now, if I wanted to find current, I would cover that one up and it would be V over R. So I is equal to the voltage divided by the resistance. And then the last one, if you wanted to find resistance and you knew the other two values, it would be resistance equals the voltage divided by the current. So that's the three ways you can use this formula. So now we're going to go through some examples. So in this first example, imagine we have a circuit where we have a 12-volt battery and a light bulb that has a resistance of 3 ohms. And we want to know the current that is flowing through this circuit. So again, we have some variables that we know. So V equals 12 volts, R is 3 ohms, and I we don't know. So we need to take a look at our formula. So remember, we have V, and then we have I and R. So we already know V, we know R. The thing we need to know is I. So I, current, is equal to the voltage divided by the resistance. So that is equal to 12 volts divided by 3 ohms, which equals 4. And our unit, remember, is amps, so 4 amps. So that is how many amps are flowing through the circuit. In this next example, we have another, imagine, flashlight. So this time we have a light bulb with a resistance of 7 ohms. And we know that the current flowing through this circuit is 2 amps. So the thing we don't know is the voltage. So V is equal to I times R. So that's equal to 2 amps times 7 ohms, which is equal to 14 volts. So our batteries are supplying 14 volts to this circuit. Our third example, we know that we have a voltage of 36 volts and a current of 4 amps, but we don't know what the resistance is. So now we're going to rearrange our formula. So R is equal to V, voltage, divided by current. So it's equal to 36 volts divided by 4 amps. That equals 9 ohms. So this light bulb has a resistance of 9 ohms. So in our last example, I've added a little extra challenge. So in this case, we're told that this circuit the light bulb has a resistance of 120 ohms, and the current is 0.050 amps. And the question is, how many 1.5 volt batteries would you need to power this circuit? So we have to do 2 calculations. First, we need to find out what the total volts is. So remember, V equals I times R. So it's equal to 120 ohms times 0.050 amps. And that is equal to 6 volts. So we know that the total circuit is powered by 6 volts. But we need to know how many 1.5 volt batteries there are. So find out how many batteries. We would divide the 6 volts by 1.5 volts per battery. So it's equal to 6 volts divided by 1.5 volts per battery. So that means that we need 4 batteries to power this circuit. So there's 2 different types of circuits. First, there are series circuits. And a series circuit is a circuit where electrons only have one path. So electrons would be flowing along here, through the light bulb, around here, through the second light bulb, and back to the battery. And that would just happen over and over again. One pathway. So because electrons can only flow in one path, if something happened to one light bulb, it's going to prevent the flow of electrons to the other. So if this light bulb flows out, this one's going to go out too, because there won't be a path because the circuit is broken. So this is an example of the old style Christmas lights that we used to put on our trees. They got really frustrating because if one light bulb blew out in the 100-strand string of lights, you wouldn't know which light bulb was the affected one, and you would have to check every single light bulb to figure out the problem. Now, in a parallel circuit, the electrons have more than one path that they can flow. So you could see in this circuit, the electrons can flow through this light bulb and back to the battery, or they can go through this light bulb and back to the battery. So in these types of circuits, if this light bulb burned out, this one would be just fine because the electrons can still flow through that circuit. So here's a little bit of information about the current and voltage and resistance in series circuits. So in a series circuit, the total current is equivalent to the current at, light bulb number 1 and the current in spot number 2. So it doesn't really matter. They're always the same. The current just is always the same. If it's 3 amps, it's 3 amps through the whole circuit, no matter where in the circuit you are. Whereas the total voltage is divided up amongst the loads. So if I had 2 light bulbs, the 2 of them combined would add up to the total voltage. So if I had like a 9-volt battery and 2 light bulbs, 4.5 volts would go through the one bulb and 4.5 volts will go through the second one. Resistance is the same thing. The total resistance is equal to the resistance of each of the loads added up together. So R1 plus R2 plus R3 and so on. So right now we're going to go through some examples to take a look at how this works. So in this case we have a circuit that has 3 resistors. One resistor has a voltage of 5 volts, this one 2 volts, and this one 7 volts is flowing through. So we want to know what the total voltage is. So we'll solve that. So V total is equal to V1 plus V2 plus V3. So it's equal to 5 volts plus 2 volts plus 7 volts. So that is equal to 14 volts. This second example, we have to do a little bit of figuring to get to our answer. So we have here, we know that the current is 4 amps and the total voltage is 24 volts. And we know that the resistor 1 has a resistance of 1 ohm. This one has a resistance of 2 ohms, but we don't know what the resistance of the third one is. So what we need to do is find out what the total resistance is and then subtract the ones we know to get the one that we're trying to find out. So the first thing that we can do is use Ohm's Law, so the V equals I times R formula, to figure out what the total resistance is. So we know the voltage and we know the current, so resistance will be equal to 24 volts divided by 4 amps. Remember, it's R equals V divided by I. So 24 volts divided by 4 amps is a total of 6 ohms. So the total resistance is 6 ohms. But we're not finished yet. We need to find out what the resistance of the third resistor is. So we need to remember, R total is equal to R1 plus R2 plus R3. So we can rearrange this a little bit. So we can move R2 and R1 to the other side of the formula to isolate R3. So R total minus R1 minus R2 is equal to R3. So now let's plug our values in. So we know that our total is 6 ohms minus 1 ohm for R1 minus 2 ohms for R2 is equal to R3. When we do the math, 6 minus 1 minus 2 is equal to 3 ohms. equals the resistance of resistor number 3.